Welcome to another video in the observability series, and in this video we'll be looking into Otel OpenTelemetry protocol. And this is really important to understand when it comes to observability because we'll be using this particular open source protocol, open source framework in multiple videos because this is one of the industry standard these days. So we'll be looking into everything about it, why it was needed, what we were using before OpenTelemetry, what are the different ways we can use it, and what are the benefits of using it. So we'll be looking into all important points. So I want you to pay attention in this because in the upcoming videos, we'll be going in depth about implementation and the usage of OpenTelemetry. Okay, so yeah, let's start with the video. But before that, if you're new here, hello, my name is 𝗵𝗺 and cloud and DevOps is what I do all day long. So let's get into the video. So we need to understand what exactly is OpenTelemetry. Okay, as I've told you, this is a universal standard for modern observability. But why this is called a universal standard and why it was needed? So let's say you have an app. Okay, you have an application deployed as a web application on which you will be implementing observability. And I'm sure from the previous videos, you have already looked into what observability is. Now, to export logs, metrics, traces, all these things from the app to a third-party system or to a backend server, we need some sort of connection. We need some sort of communication channel, right? If we are using Elastic, if you are using Grafana, if you are using Honeycomb, all these observability tools, if you are using Datadog or any other tools, right? It needs some sort of agent, some sort of plugin that translate application data or application metrics and everything to the language that these application understands, right? So there was nothing like that before OpenTelemetry. So earlier, before 2019, people were using different agents for different application. Like if you were using Datadog, so then you were using Datadog agent to transfer that data, to translate the data. If you were using New Relic, then you were using New Relic agent, Jaeger SDK, and so on. Right now we have one universal standard format, because this is OpenTelemetry protocol. So this is a protocol that is standardized, that is being used by all the applications. It supports every single application. So earlier, we used to be switching between multiple vendors, right? And because when you were switching between multiple vendors like Datadog, New Relic, Honeycomb, and whatever, right? It incur you a lot of cost because developer has to then rewrite the application code from scratch to implement traces, to implement telemetry and everything. Now it can be done simply with just a change in the config YAML file provided by OpenTelemetry, the image that you can see on the right. It's pretty easy, straightforward, and it's almost zero cost solution with OpenTelemetry. Earlier you were vendor logged in because again the same thing, you have deployed OpenTelemetry or you have deployed a third-party solution, you have bought their subscription and you have implemented the code and everything. Now you are vendor logged in. But now, because this OpenTelemetry, it supports multiple backends, multiple monitoring and observability systems such as Elastic, Grafana, Honeycomb, AWS, Google, Datadog, Azure, and so on. You can use the same OpenTelemetry to export the data to multiple backends using Otel collector. Okay, Otel collector is something that helps you transport the data to multiple backend systems. Earlier, the maintenance was high because you were managing multiple fragmented agents if you are using multiple tools, right? But now you are using just one single tool, one single protocol, OpenTelemetry, which is maintained by CNCF. It's a Cloud Native Computing Foundation project. And that means you get a huge community support, plus it's open source, plus it's free, it's OpenTelemetry, right? So that's the main difference between before OpenTelemetry and how OpenTelemetry helped resolve all the issues that we had before. Now, it's also referred to as USB-C of observability, right? What do we mean by USB-C of observability? Let's understand this. So as I've told you, you have an application, right? And now application has to be connected to multiple backend systems for monitoring and observability, right? Datadog, New Relic, Jaeger, and so on. Now, each of these backend systems have different connection endpoints, like you used to use different agents. And if we talk that in the analogy of a socket and switch, you see we have different adapter types. Some is 2-pin adapter, 3-pin adapter, and so on, right? So there were different adapters, each for different tool. But now we have a universal protocol like USB-C. Now you can use USB-C, which is a universal protocol. Again, USB-C is one of the universal port that we use with devices these days, so that you can connect your Apple and Samsung and Android phone to the same charger, right? The same way you can connect your application with multiple backends using the same Otel connector. And this is because it's a universal port. Otel has 4 core components, okay? The API, the SDK, auto instrumentation, and collector. Okay, so let's look at these with the help of analogies again. So the API, which is the menu, okay, it's the universal set of instructions. Now we are saying start a span, emit a log. So it lists down the options. It doesn't cook the food. It is stable and vendor neutral. That means it is providing the ability to perform certain actions on the back end. Okay, so that's the API component. Then we have the SDK. SDK is where you implement the code which handles batching data and retries if the network fails, and sampling data. Here's your actual logic will be written over there. Then we have auto instrumentation. Auto instrumentation that records all the HTTP calls and DB query automatically. Again, there is zero manual code, but it will record all the activities that are being happening on your application. Then we have Otel collector. Otel collector is something that receives telemetry from your app, filters it, and then route it to the backend you configure. Okay, so your application, consider this as the collector, the post office, right? So it receives your letter and it filters which letters belong to which address, and then it routes it to that backend. So these are the 4 core components of OpenTelemetry. Now we have something called as the connective tissue. There is a term called OTLP and context propagation. So OTLP is OpenTelemetry protocol because this is a universal standard. This is something that is being used by multiple applications. So there has to be certain rules, certain language that it has to follow, right? So this OTLP, OpenTelemetry protocol, that governs that language and that governs that standardization. Okay, so this is the agreed upon language telemetry travels in. When you see the OTLP endpoint, this is where you point your data. Okay, then we have context propagation. Context propagation means the parcel tracking number. A unique trace ID is injected into the HTTP header, and that stitch a single user request across multiple distinct services. For example, let's say we have 3 services. This is your front end, this is your back end, this is your database, let's assume. When the request goes through front end, the request will get a unique trace ID, right? For example, I have logged into the system. So for my request, a unique trace ID will be injected to the HTTP header over here. And then from wherever my requests flow from service A to B to C to D, how many services, doesn't matter. That trace ID will be attached to the HTTP header so that it records all the activities that I have done after I logged into the application. Okay, so a unique trace ID is attached so that we can just check the end-to-end flow of a particular trace or a particular request using the trace ID, and that is what we call context propagation. Okay, so the full journey of a trace, how it looks like end-to-end from the application to the destination backends. So there is a trigger. Okay, so let's say if you are on an e-commerce website, you click on checkout. So that's the trigger when your journey starts. This is where we need to capture user behavior, right? So why we need to capture it? So for example, we want to know how many users are adding the product to the cart but not doing the checkout, or how many users have done the checkout and come back again, or which particular users have done the checkout and return the product, something like that, right? So we are just tracing, or we are just tracking the request for a particular flow. Okay, so the trigger is user clicks the checkout button. Okay, and then we have auto instrumentation, which generates the span, which is again a component of OpenTelemetry, right? Then there is a barcode, which is context propagation attaches trace ID. So remember in the previous slide, we looked into the trace ID attached to the particular trace, right? So this is what happens over here, context propagation, which attach the trace ID to that particular request. Then we have SDK that batches the data. And there is this language, the data travels via OTLP, which is the Open Telemetry Protocol. And then we have collector that filters and routes the traffic to the particular backend. Okay, so all the components in the same sequence: auto instrumentation, context propagation, then we have SDK, OLTP, and then there is this collector. Okay, and this collector then transfer the data or transfer the trace to the third-party monitoring and observability system that we are using: Prometheus, Jaeger, and Elastic, Honeycomb, and so on. So that's the end-to-end journey of a trace. Okay, I'll plan to do another video in which we'll deploy it and you'll see that in action. How does it look like and what are the benefits of using it? But for this video, I just wanted to cover the basics of it, the fundamentals. This is how a collector YAML look like. Okay, so we have something called as receiver, exporters, and service. Receivers are how are you receiving your data, right? So let's say we have mentioned we are using OTLP, Open Telemetry Protocol. Inside that we are getting it from gRPC and HTTP. gRPC is when we are transferring data between multiple web services or multiple services within a microservice architecture, and then HTTP, I'm sure you are aware of that. So now these receivers listen for the OTLP traffic from the app services, and then it sends it to the router. Router is nothing but what we configure in the exporters, right? Exporter are different tools, different third-party tools, monitoring, Jaeger, Elastic, and so on. And then if you want to add more tools to it, you just add an entry over here in the exporter, let's say Elastic, Honeycomb, and it will be done. Okay, so just that it, you don't have to write the code as I've told you earlier. Okay, so just that you define the backend over here in the exporter, and then we have services. In the service, you define the pipeline. So what do we need? We need traces. And what are the receivers? The receiver is OTLP over here. Exporter is this, right? You define different pipeline services over here, keeping these two as different elements. Okay, and basically that's it. It will just transfer your data to the destination that you have configured, right? So that's how simple it is to configure the collector. Now let's understand the trace waterfall. Okay, so trace is, because I've told you, right, a unique trace ID is attached to the particular session or to the particular context. And through that trace ID, you can identify issues, identify bottlenecks, latencies, and so on. So let's say your checkout service, the checkout workflow is showing some latency. Okay, so how you can trace? Because you have a trace ID attached to it, you will see the end-to-end request and response time of each of these services when it flows from one service to another. And then you can easily find out, okay, so there was the issue at the checkout service, and this could be the bottleneck because it took the longest time in the entire trace. Right? So that's how you detect the issues, and it is easy to detect the issues because now you know exactly where to look for. And this is how basically all the traces and all the services will look like. Okay, so here are your different sessions, here are your different contexts with the unique trace ID and span ID, and it provides you the time it took for the service to respond. Like this is for checkout service, for payment service, for front-end service. And here is where the request comes in and goes from one service to another. Now you know which service took the time and which service basically shows the highest time taken. Okay, and here it says 120 microseconds for checkout. That means we need to check over here what's the issue with the checkout service. So how does this Otel impact different type of user persona in an organization, such as developers, DevOps engineers, and platform engineers? So with developers, now they don't have to learn different APIs written in different language. They just learn one standard API and that's it. Now with Otel, they can instrument the code once and they don't have to rewrite the instrumentation code again, because even if you change the vendor, even if you go with another product, the instrumentation code remains the same in the language that is supported by Otel. Okay. Then for DevOps engineer, the pipeline that you have is vendor neutral. It's basically a YAML pipeline and it won't change for different vendors. You just have to add a few config entries for different vendor and that's all about it. The one that we saw was an example. Then Otel impact is you own the routing config and evaluate new observability platform by simply pointing the collector to a new destination to test it. Okay. And for platform engineers, now you have been mandated infrastructure standard, okay, because we are using one standard again. And then it controls sampling rates, PII scrubbing. PII is personally identifiable information like your email, your phone number, address, and so on. It comes under PII. So it helps with that PII scrubbing and backend destination globally from a single collector fleet. Okay. So these are all the benefits of using Otel for different user persona in an organization. So the core takeaways of this lesson, I think that's the last slide. Yes. So the core takeaways are Otel is one open standard platform provided by CNCF and it works with any backend. You just write your instrumentation code once and send it anywhere. There are 4 core components of it: the API, SDK, auto instrumentation, and collector, and it helps with the end-to-end life cycle of a trace. Then we have the connective issue. So we have OTLP, which is the language telemetry travels in. This is the OpenTelemetry protocol. And then we have context propagation. That means that stitches the similar requests together with the help of a unique trace ID. Then we have a zero code barrier in which auto instrumentation libraries and collector configuration are enough to go from zero to full traces without touching application code. You just write it once and reuse it every time. Even if you switch the vendor, even if you use any other tool in the backend for monitoring and observability, you will still use the same code. You don't have to rewrite it. So it ends up saving a lot of time. It helps saving a lot of efforts. Plus it's supported by CNCF community. So you have a great support with that. Alright, so that's it for this video. Thank you so much for watching. I hope you enjoy it. I hope you like it. I will see you soon with the next one. Thank you and happy learning.